Gold mining has excited the imagination of treasure hunters for centuries. But the mountains of electronic waste are just as viable a source of treasure as the earth itself. Gold is used in circuitry because it is highly conductive to electricity and resistant to corrosion. Today, that boneyard of waste is being mined here in the United States. Colt Refining in New England uses several methods to extract gold and precious metals from e-waste.
There are a number of processes that happen here, depending on the material that comes in. We deal in different industries, but the items that we handle go a certain path based on the metal content. We have other materials that come in that are of higher grade, they're a little bit cleaner. They would then go on to a different set of processes. They would either go through a burning process, a melting process, or a chemical stripping process to extract precious metals.
Determining the exact makeup of alloys is the first step.
It's an X-ray device that identifies the metallic content of an item. It only identifies the metallic content, so if it's a mixture of plastic and metal, it'll only tell you the metal that's in it. So we scan all materials coming in, all different types of base metals with that gun to determine the type of metal it is. It could be an aluminum, a copper, a stainless steel, a tin, a nickel. The gun will allow us to QC that in the door, so we're not guessing or using other types of simple tests to determine, the metallic content.
Once they know what they're dealing with, Colt decides which process will be used to extract the precious metals. The metals as minute as dust particles on equipment and clothes are sent to the incinerator.
In the process of manufacturing, anyone who uses precious metals in the industry generates waste in the form of wipes or anything that comes in contact with that product. A piece of wood, a Q-tip, things along those lines. That would be incinerated.
All this material adds up to mountains waiting to be mined.
Something like that, you would say, have 20,000 pounds of a shipment might go in our incinerator. And that incinerator, we can burn 3,000 pounds per day. It may burn down to 10,000 pounds and lose 50% of its weight.
Everything in the incinerator is reduced to ash. Then it is sent to the ball mill for grinding. The mill uses steel balls from 1 to 4 inches in size to grind the particles for roughly an hour.
In this powder or sweeps, you're going to have oversized particles of molten metal, as well as the ash. The next step would go through sifting process, where we have orbital sifter. We screen our material down to 60 mesh, which is pretty much 60 holes per square inch.
So what you would end up with is a very fine talcum powder. And then anything that was left on top of the screen, we would determine whether it needs to be milled again or possibly melted.
After the sifting process, the powder is placed in a rotary tumbler for final mixing and blending.
If it has gold and silver present, then we would use a traditional fire assay method to determine the percentage of gold and silver within that powder.
A sample of the powder is taken to the lab where it is rolled by hand to further ensure it's evenly blended. The powder sample is divided into 3-gram portions and mixed with the flux in a crucible.
The flux is a standard mixture of lead oxide, soda ash, borax, silica, some flour.
Each crucible containing the mix is marked with an assay number that matches the customer's package of powder.
After he's weighed these sweeps, he will take the material and put them in a muffle. The muffle is an electric oven, basically.
The samples are baked for 45 minutes at 1600 degrees Fahrenheit.
What's going on at that time is a miniature smelting operation.
The metals, such as gold, silver, and platinum, are collected in the lead-based flux, while the impurities separate as slag surrounding the precious metals.
Well, after he pours these off and allows them to cool, the lead button is hammered of all the slag.
The muffle is recharged to 1600 degrees and filled with a smaller dish called cupels.
It's a bone ash mixture, hard pressed. They're very absorbent. We'll put the lead buttons into those cupels. We will leave those in until all of the lead has been evaporated. All that's going to be left in there is going to be total precious metal. We'd call that a TPM.
They incinerate materials and pulverize in ball mills, but Colt also uses cyanide.
The chemical stripping process starts with a customer's material or our own material that we've segregated. It would be put into one of 3 different processing lines that would take the material and dip it into a cyanide-based solution, which would actually strip the exposed gold off of the substrate. And the substrate could be a circuit board, it could be a connector, it could be some other type of electronic device that has exposed gold. So the gold ends up suspended in the solution. The solution consists of 99% water. There's a small amount of cyanide added and a chemical stripping agent that kind of activates the solution, and it creates the chemical process that attacks the gold.
Each batch of material is soaked for 3 to 5 minutes. In that time, the gold is stripped from the circuit boards.
The basket would then be moved over and rinsed, and then at that point it is dumped, and that material is sent out for whatever metallic content is left in it. We would then take that solution, pump the solution out and spin it, make sure it's homogeneous, and take a sample of that solution. And after we remove a portion of the water, we pump it over into a plate-out tank where we actually plate the gold out of the solution onto cathodes. The basic concept is that you have a cathode that's charged electrically, and we have the solution that passes through the cathode, and over the course of several days, all the gold attaches to the cathode and leaves the solution.
The solution is checked continuously until it is totally free of gold. The cathode is then removed and dried in an oven.
That material is cracked into smaller pieces so it will fit into our high-grade melting furnace and slowly instituted into a melt. It takes approximately an hour to get that melt down to a molten metal, at which point we can take a pin sample, which is representative of the homogeneous melt, and then we can pour a bar. After we pour one of these cathode melts, we take the bar. After it's cooled, we clean it and we weigh it, and we perform our assay work so that we could determine an exact amount of gold in one of these bars. These bars usually average 350 to 400 troy ounces of gold.
The gold and other precious metals Colt recovers are sent to special facilities who are able to refine the metals to close to 99% pure. The refined metals are then returned to Colt.
So what you see here on this table are examples of different products that we would take back that were made out of the refinable products that we created. We have examples of silver bars, gold grain shot material, gold coins, and in some cases we provide this material back to our customers.
Gold recycled from electronic circuit boards is the final product of these machines. But for those that are not melted or scrapped, they may bide their time waiting in the wings before being transformed for a totally new role.